Welcome to qnawire.
In this question, we have this setup or this arrangement of three charges. So the 5 microcoulomb, the plus 5 microcoulomb, and the minus 5 microcoulomb charges, they form a dipole. Okay, so there are two parts in the question. We want to find the net force that the 10 microcoulomb charge exerts on the dipole and the torque. Okay, so first thing, okay, to find the net force. Okay, so this is Coulomb's law. Okay, so using Coulomb's law, okay, and then we just find the force on the individual charge, like the individual plus and minus 5 microcoulomb charge by the negative 10 microcoulomb charge. Okay, so F, the electric force is K Q1 Q2 divided by R squared. Okay, so on the 5 microcoulomb charge, okay, this is the electric force, and then on the negative 5 microcoulomb charge, this is the electric force. Okay, so just to draw it better. Okay, so this is F1 and then this is F2. Okay, and then by symmetry, okay, by what I meant here is equidistant. Okay, so F1 is equal to F2 in magnitude. Okay, and then and if you look at the geometry from the arrangement, okay, the horizontal components of F1 and F2 cancel out. Okay, so we only need to sum the vertical components. Okay, so this is the angle that we are interested in. Okay, and this part would be 1.5 meters, 1.5 cm, sorry. Yeah. So and the based on the diagram, the vertical component will be the cosine theta. Okay. So F net, okay, or the magnitude of the net force, magnitude of the net force. Okay, so this is equal to 2F1 cosine theta. Okay, so we know that they have the same magnitude, and then the horizontal components cancel out. So the vertical components, they just sum, and then it becomes 2F1 cosine theta. Okay, and then F1 would just be K Q1 Q2 divided by R squared cosine theta. So Q1 is Q1 is the 5 microcoulomb. I'm just going to write micro, and then the Q2 is 10 microcoulomb. Okay, and then divide by R. R in this case is 2 cm, so 0.02 meters. And then you square it, cosine theta from the diagram. Okay, so you have 1.5, you have 2 as the hypotenuse, so it becomes 1.5 divided by 2. Okay, and you do this, you get 1690 newtons. Okay, and then the direction of the net force, okay, it is downward. Okay, so this is magnitude and direction of the net force. So this is part A. Okay, next we move on to part B. Part B is to find the net torque. Okay, so we just have the diagram again, and the forces are pointing in this way. Right, so okay, just put down the distances again. So this is 3 cm, 2 cm, and 2 cm. Okay, and we still need this angle. Okay, so to find the torque, okay, the formula is RF sine theta. So we actually need to choose a reference point. Okay, consider the torque at the negative 5 microcoulomb charge. Okay, yeah, the reason why I do that is because it's going to be like a couple. So although couple there is no net force, but we can still take the torque, consider the torque by one at one of the charge, and then about one of the charge, and then and you'll still be able to calculate the torque. Okay, so this is our reference point, and so F2 is not needed in our calculation. Okay, so the torque would be R F1 sine theta. Okay, so so the R will actually be pointing in this direction, right? Yeah, and then the sine theta is actually this obtuse angle, but sine of this obtuse angle is equal to the sine of this acute angle. Okay, so we can still use the theta over there, and so R is 3 cm. Okay, F1 is the kq1 q2 divided by r squared from the previous question. So kq1 q2 divided by r squared, and then the sine theta. Okay, so here we can easily find the cosine theta. So cosine theta is 1.5 divided by 2, which is 0.75, and sine theta will just be 1 minus cosine squared theta square root. Okay, using Pythagoras theorem, so you get 1 minus 3/4 square and square root. Okay, so you get 7/16 square root. Okay, so that's the value of sine theta, but you can actually just use calculator to store it. Okay, so I'm just going to write sine theta over here. Okay, and then just continue. Okay, put in all the numbers. Okay, when you do this, and you calculate the torque to be 22.3 Newton meter. Okay, and the direction, okay, it is clockwise. Okay, so these are the answers for part B. Okay, and that's all for this question.